Hello everyone, welcome to day 4 of simplifying and multiplying rational expressions. Okay, so now we're going to start taking some of those things we're doing in the last couple days here with simplifying them, and we're going to start multiplying and doing some funky thing with these things. Okay, so rational expression is a over b, where b is not equal to 0. Remember, you cannot have anything, cannot have a 0 in the denominator. You can't even type that into your calculator. This is what we call undefined, okay? And so in all of these problems, b cannot be equal to 0. So just know that as you continue on here. Simplest form, rational expression is in the simplest form of the numerator and denominator have no common factors except 1. Okay, so to simplify rational expressions, you need to factor first, then cancel common factors from one numerator and one from the denominator. Okay, so let's take a look at this first piece. Okay, now a lot of kids would be like, "Ooh, sweet, cancel." Okay, wrong. Okay, in order to just cancel things, you need to have them factored. Okay, this one in the bottom here is not factored. Okay, and so in order to simplify like that, you need to have all multiplication on the bottom. Okay, and so let's start with that. So we're going to have x squared, because we can't do anything else with that. But in the bottom, we can take out an x, and that leaves us with x plus 4. Okay, so now in the bottom, okay, this expression has been factored. Okay, we're just multiplying down below here now. All right, so granted, you do see like you see this right here, and you're like, well, we're adding right there. Yeah, but it's just some number, okay, which is just picture as some number. Okay, we're multiplying a number by the same number plus 4. So we're multiplying by two numbers down here. So we're factored, okay? And once we have factors, we don't have any addition or subtraction floating around down here, okay? Then we can cancel. So now we chop one of those off. We're left with x in the top and x plus 4 on the bottom. Okay, so just remember, when you go to simplify these expressions, you need to make sure that you're just doing nothing but multiplying on the numerator, or in the numerator and in the denominator. Okay, so let's look at the next one. Okay, hopefully you guys are recognizing that top piece. That top piece is a difference of two squares, x plus 3, x minus 3. Okay, that's why I was trying to emphasize it's just important to recognize those as quickly as possible, because then we just kind of move on. Okay, down and below, I'm going to take out a negative 2. So when I take out a negative 2, I'm left with x plus 3. Okay, now I can simplify things. I got nothing but multiplication in the top and the bottom. I don't have any addition or subtraction just floating around on their own. So now I can cancel. So I'll cancel these guys here. And I'm left with x minus 3 over a negative 2. Okay, and we can just leave it just like that. Okay, let's move on here. All right, these are going to start getting relatively harder. Okay, so this next one, all right, it's got a funky rule here with it. Okay, so I want to talk about this for a second. They look very close, right? All right, so let me adjust this real quick. Whoops. Okay, there's a special rule that goes with this one. Okay. Oops, crap. Let me draw my parentheses. So I'm going to go negative x plus 5. Okay, I didn't change the value of anything there. Okay, I changed the value of that. Addition's commutative, right? We still have a negative x, and we still have a positive 5, okay? Now, I'm going to take out a negative 1. Okay? All I did was just undistribute. If I took this and I multiplied it back in, we would get the same thing over here. Okay? So all I did was kind of just undistribute, or I took out a negative 1. And by doing so, now you look, oh, wait a second. This looks like these two things could cancel, right? Which they can. They cancel, and you're left with a negative 1. Okay, so the rule here is, if you have a minus b over b minus a, that is just equal to a -1. Okay, so as we continue on, hopefully you guys will recognize those, and so you won't just immediately go and cancel them, but you'll know that they don't cancel to 1, they cancel to -1. All right, so we will see more of those as we continue on here, but just know if you see something like this, this equals -1. Okay, let's move on over here. Okay, ooh, we got a big one here. All right, let's go. Let's do it. So, hopefully on the bottom you recognize that that is a sum of perfect cubes. Okay, but on the top we're going to have to do some factor by grouping. So I'm going to have to kind of group it like this up on the top here. Okay, so you guys can see it. So in the top piece, right, I'm going to take out a x squared. By doing so, I'm left with x plus 3. Okay? On the other side here, I'm going to take out a -2. And again, that leaves me with a x plus 3. All over. Now I'm just going to separate this already. Okay? Our a value is going to be x. B value is going to be 3. So it's going to be x plus 3, x squared minus 3x plus 9. Simplify that stuff in the top, so x squared minus 2, x plus 3, and on the bottom, x plus 3, x squared minus 3x plus 9. Okay, so let's see what we can cancel. Well, obviously we can cancel these two things. We know this is simplified, and this is not a difference of 2 squares. 2 is one of our prime numbers. All right, so it cannot be simplified any further. So our answer is x squared minus 2 all over x squared minus 3x plus 9. That is our answer. Okay, let's move on to the ones down below here. So multiplying rational expressions, okay? Factor first, cancel common cancel common factors when you can, and then multiply. All right, so the idea here is you want to try to make this as simple as you can first before you start multiplying things together. All right, so you want to try to simplify on either side. Now in this first one, there's really not a whole lot we can simplify in that first piece here, right? 2x squared over 5y. Okay, but we can simplify a little bit on the right side. Okay, 10 divided by 5 is 2, so you have 2y cubed all over 5x squared. Okay, no, not 5, sorry. That guy is gone. Okay, so what do we have left? All right, now we could just simply multiply those together, okay, and then cancel, but I'm going to kind of just cancel while they're sitting here like this. So my x squareds will cancel. Okay, my y's will cancel. I'll be left with a y squared. And so finally, what do I have left here? So I have a 2, I have a 5, I have a 2, and I have a y squared. So we pull all this together. So we have 2 times 2y squared all over 5, which is 4y squared divided by 5. So that is the answer to the first one. Let's take a look at the second one. Okay, the second one, all right, make sure that's correct there. I kind of rushed through that one. Yeah, we're good. That's it. Okay, so let's look at example 6. Okay, so I'm going to simplify a few things. On the left, that first piece, I'm going to take out an x. Be left with an x minus 6 all over 6 minus x. Hopefully you guys are jumping out of your skin a little bit there. All right, I'm going to take out a 2 in this next piece, so I'm going to be left with x plus 4. And I'm going to take out another x here, and be left with a x plus 4. Okay, let's do some cancellations. do the easy ones first. This is gone. This is gone. I can cancel these x's. Okay. And so let's talk about this piece right here. This piece, if you remember, a minus b over b minus a is equal to -1. So this just cancels to a -1. I circle it so I don't lose it, and then I'm left with a 2. So really, I have a -1 times 2, which is just equal to a -2. Let's keep going. Example 7. Okay. This one looks real funky. All right. So on this first piece, I notice a dots problem, DOTS, difference of two squares, and a sum of perfect cubes. Okay. So let's take care of those guys real quick. So this first piece is going to be 3 minus x, 3 plus x, and on the bottom, we're going to have x plus 3, x squared, plus 3x, plus 9. Multiplied. Okay, so in this next piece, I'm going to take out a GCF from this piece here. So I'm going to take out a -3. And so I'm left with a positive x squared minus 3x plus 9. Oh. Uh-oh. And then I'm going to take out a 6 here. So we'll be left with x plus 3. Okay. So let's get down to some cancellations here. All right, so I know you're thinking, well, what about these guys right here? Well, because addition's commutative, these can still cancel. Okay? So we're good there. All right, I guess I could have canceled from the left there. It doesn't matter. All right, these will cancel. Okay. These do not turn into -1. Okay, so don't even think about it. Okay? It only works when it's a minus b or b minus a. That bottom one has a plus sign in it. So don't be fooled by that. That does not become -1. Okay? So, what do we have left here? We have a -3 times 3 minus x all over a 6 times x plus 3. This will become a 1. This will become a 2. So now we have a -3 minus x all over 2 x plus 3. But wait a second. I can distribute that negative sign, right? Okay. -3 plus x. There we go. And I can even further simplify this, make it look nice. X minus 3 over 2 x plus 3. There's our answer. Okay. The rest is for homework. Let me see what you guys got down here. Only 6 problems. Okay. I would say pick 5. All right, so you don't have to do one of those. Okay, so pick 5 questions. You can do any 5. But you need to do 5. Okay? So if you don't like that number 6, don't do it. But make sure you do 1.